I'll solve one problem on development of lateral surfaces. So here I have taken the example where it is given as develop the lateral surface of the cylinder of 40 mm diameter and height is 60 mm, which is cut in the right side figure. So here in the figure you can observe the diameter of the cylinder is 40 mm and the height is 60 mm, and it is cut in such a way that you can observe. So from the bottom there is a plane which is cutting the cylinder at 30 degree, so that is a Vt. So Vt is a vertical trace. So that plane which is cutting the cylinder is perpendicular to Vp and inclined to Hp at 30 degrees. So that is one plane. The next plane at the top you can observe, that is inclined to 45 degree from the above corner, and it is passing through this point. Then one more plane which is cut by 60 degree Vt vertical trace, so that is inclined to 60 degree from the axis of the cylinder. Okay, so that is given in the problem, and I will draw the development of this cylinder lateral surfaces. And lateral surface in the sense we are going to draw only the side surfaces of the any given solid, and we are not concentrating on top and bottom surfaces. So let me start now. So just I will open the software. So in this solid edge software, now I will draw the top and front view of the cylinder, so that from that cutting points we can develop the surfaces. So first I will draw the top view of the cylinder. So again I will take the circle option that you know. So from this circle I will draw the diameter of 40 mm. So this is the 40 mm diameter top view of the cylinder. Okay. Now after this you just draw the front view. So take the XY line of thickness 0.05. So this is the XY line, and name it. So X and Y. Okay. Now after this so take the XY line of thickness 0.05. So this is the XY line, and name it. So X and Y. Take one line from this end and draw the projection lines by thin lines. Okay. Now take the thick line of 0.5 mm to draw the front view of cylinder. So these things you know in projection of solid as well as planes. So the height of the cylinder given is 60 mm. So take the 60 mm height of the cylinder, and this is the diameter. So this is the diameter 40, and complete the cylinder in the front view. Okay. Now I don't know where it is cutting or which place they are going to use to cut the cylinder. So simple, what I will do is first I will develop the lateral surface of this complete cylinder, then I will divide it into number of planes, then I will take the planes which are cutting the cylinder, so that we can draw the development of that cut cylinder. So simply what we can do is, so we can measure the dimensions. So the dimension of this cylinder is 40 mm diameter and height is 60 mm. So if you develop the simple given cylinder, if you imagine the cylinder is made up of thin sheet, So what I can do is I can just draw one continuous line. So if I cut and open the cylinder from this corner, any of the corner, if I cut it and if I open the cylinder, so the lateral surfaces will be in the shape of rectangle. So that height of the rectangle will be again 60. So again on the same line you can take, the height is 60, so just you can touch here. So since it is a cylinder or in the prism, so all the side edges are parallel to each other. So that 60 mm height I will take, and I can draw total length of the sheet which is required to develop this cylinder. So the total length of the cylinder can be given by pi into d. So d already we know, that is 40 mm, and pi you can multiply with that, so that it becomes complete circumference of the cylinder surface. So now I will just take the pi d value. So that pi d value, if you multiply with 40 and pi, I will get 125.68. Okay. After this, just I will complete this development. So this will be a simple sheet. So that you can understand by that video. So just join this rectangle. Now this simple development of the sheet is over. Now just observe, I will draw the front view. So in that front view I will take the vertical traces. So those planes are cutting the cylinder in respective positions. So first I will take from this corner, I will take one line. So it may be continuous or it may be some dashed line, so that it will be a transverse line which is cutting the cylinder. So that line I will take of thickness 0.5 again. So from this corner, so the angle given is, so observe here, so this angle given is 30. So that angle I will take here 30 degrees up to this edge. Okay. Now from upper part they have taken from this corner, so that angle is 45 degrees. Okay, this is minus 45. Okay, so minus 45 is opposite. Now see up to what it has to be taken. So you can observe here. So roughly if you can observe, the 60 degrees from axis actually, and up to axis this 45 degree line is coming and touching here. So that I am drawing up to axis. Okay. Now after this axis, so this line with the axis it is 60. So this is 90 now. 90 then 60. So what is the angle now? So total remaining angle is 30. So that angle you can give here. Angle 30. Just enter. And it is crossing the edge here. Or else you can show the dimensions. So better to show the dimensions, distance between this to this is, so angle between to this is 45 degrees. Angle between these two is 30 degrees. And also you can draw the axis of thin line. So this axis I will draw from the midpoint to this midpoint. Now I measure the angle. From this to this it is 60. Okay, I hope this you have understood in the front view. Now if I want to show these cut portions on this plane, I don't know the points where the curve is crossing. So what we are doing is, in cone or cylinder, as we don't know any real edges, so now we have to divide the circle or the cylinder into number of parts, and those number of parts in the front view we are getting the imaginary edges. Those are called as trajectories. So from that imaginary edges I can find out the points where the plane is cutting the cylinder. So those points I will project it on the sheet. So just observe how to divide the circle. So better you can divide this circle into more number of parts. So in the planes and solids we have taken around 8 parts, but in the development it is better to take 12 parts, so that whatever the cut portions is there in the cylinder part, it will be smooth curve and it will be very fine and accurate. So to divide the circle, see the procedure now. So I will take the number of parts. So first what you do is draw one line here from the center to any side. So from this center you draw any line, thin line. So already it is thin line, so thin line I will draw it. Then I will make a pattern. So how to make a pattern here? Just click the one line, take the circular pattern. Now see, from this as a center I want to make pattern of these lines. So just before clicking, or just click it, then you enter the angle. So this is total is 360 and count is, so number of parts we want is 12. Enter. Then finish. So just you can observe now, I have divided the circle into 12 parts. So after dividing any solid or any plane, you just first give the namings. So F1 and H1 and G1. So like this I have given the naming now. So bottom you can give same thing, A from here to up to G, and behind from G to A. So this you can name it. And later what you can observe here is the remaining cylinder is only this inside part. So as we know that whatever the upper part is removed is taken outside, and we are neglecting in the development, and here also bottom is removed and only retained part is this center part. So what I will do is these lines, this line I will make it thin line, so there will be less confusion later. Then this line is also thin, and this line you can split it. So split command you can observe here. So split command is here with a trim. So click on the line, and where you want to split it, see, I want to split at this end point. Click here. Again select that line. Already it is splitted here. I want to split again at this point. See, this point I want to split. Click. Now observe, if you select this line, it is only selecting only part of the line. So these two lines I will make it thin lines. Done. Now this solid is looking like this. So now I have prepared the complete given question. Now I have to solve this. So go to this line. So I want 12 parts in the sheet. So better what you can take is, you can take the distance between these two lines. So that distance is, total is how much? Total is 125.68, and I want to divide this into 12 parts as I have taken here. So you can take one distance, that is by 12, and go on dividing this line, or else better is go to offset command. So this is the offset command. Click here and click on the line where you want to start the offset. So better you can take only one line. So delete these lines which are not required now. Now see, take offset command, click on this line. Now total distance is 125.68. This I want to divide by 12 parts. Enter. What is the distance? 10.47 for each part. That is from A to B, B to C, C to D is 10.47. So go on clicking on the right side. See, you can click on left or right. So I have space in left side, so click here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. Done. Now joined by thin lines. from here to here. So this length also you can observe 125.68, correct. Make it thin, and I don't want these dimensions, so remove it. Then show the dimensions only where it is required. So I want complete length 125.68 and I want only this much. So this you have to show for taking the dimension from A to B, how much it is, or for each distance what is the parts we have taken. Now start with the naming. See, now these cylinder imaginary edges are cutted by these vertical trace lines. So at some points, so that I will give it by some numbers. So always in development where the solid is removed or cut into different parts, so there you have to give by naming by numbers. So I'll name it by different numbers. So go to text again, so reduce the text command, so that's 2.5 you take, enough. See, now first is only one corner, so that corner is, I will name it as 1 dash in front view. This is 1 dash from A line, it is cutting. Then it is 2 dash in front, which is cutting B line. Then 3 dash. Next is 4 dash. Then 5 dash in the front, which is cutting E dash. This is 6 dash. Last is 7 dash. Now come in the behind. Now I have completed in the front. So 1, 2, 3, 4, 5, 6, 7. So these are the points in the front. And behind it goes like this. Now 8 on H. 8 dash, 9 dash, 10 dash, 11 dash, and last is 12 dash. So this I will complete first. So don't draw all the points, all the namings, and don't project here, so you may be in confusion. So one by one you do. Now after this 30-degree line, I know namings where it is cutting, so those numbers I can name it here. So better in prism and cylinder, as all the edges are parallel to each other, okay, and also height is equal to the height of this sheet which is developed. So directly you can take the projection lines from these numbers. So go to projection line, okay, of thickness 0.05, enter. Now see, from 1 already there is one line, I will just take it here, means 1 is starting from this A. Now 2, or better you name the sheet here first. So take naming here. So this is A, so that I will name it by capital A. Why? Because this is the actual view of the sheet which is required to develop this solid. If you roll this complete sheet, it will provide this type of cylinder, okay. So that is, since it is actual sheet which is required to develop the cylinder, so I will give the naming as capital A. So continue it. So this will be B, C, D, E, F, G, H, I, J, K, L, and what is next after L? Again A. Means what? If I roll this complete sheet keeping A to G in front of the observer and G to A, I will rotate behind. So this A, from behind it will come and contact with the A, and on this A line, so if you see the workshop, in the workshop what we can do is, this A line and this A line is joined and welded or soldered, so that at radius 40 mm if you roll it and join at both the A lines, it will become a cylinder. Now observe the cut portions. So I will take the projection lines, or else you can measure the distance from this B line or K line and you can point it here. So better to take the projection lines. So take the projection lines from this intersection of these two lines up to 2 is B. Then next is 2 and 12. 12 is what? On L it is. So up to L I can draw this line. Okay. So up to L. So better what you can do is, angle you can give 0 and enter. So if you keep on moving the cursor, still the line angle will not change. It will be on the straight horizontal line. So click up to L. Done. Now I got 2 and 12. So name it first. Don't draw anything before or after naming. First name it. Okay. Always name first, then go for drawing. So there will be less confusions. Also in planes and solids you follow the same procedure. So go to naming. So on A I have named it 1. Okay. So dash is not required because it is actual. On B I have named 2. On L I have named 12. Done. And again on A is 1. Is it clear? Now come to C. So on C and K, 3 and 11 are coming. So from this again you take the projection line from this intersection. So go to tools. So I don't want this midpoint or something, I want only intersection. So from this intersection of two lines I will draw up to K. Why? Because on C and K it is cutting. If I open it, now again go to naming. So on C it is 3, on K it is 11. Done. Now go to another projection line, that is 10. So 10 and 4 are coming on J and D respectively. Take this line up to J, you can mark it. Enough. So name it. What are these points now? This is 4 in front of the observer and 10 is behind the observer. Now go to this projection line. Next, 5 and 9. So these cutting points, 5 is in front of the observer, it is cutting E line, and 9 is the behind the observer, which is cutting the I line or the I imaginary edge. So up to I can draw that. Then last is 6 and 8. So from this intersection again, so 6 and 8 is cutting on F and H line. Okay. Then last is 7. So on 7 there is only one corner, that is G. So only one point will be taken. So that is G. So if it is again changing the angle, so fix that angle 0. Enter. So up to G I want this line. Okay. So this is completed. Now name it properly. See now, if you draw all the lines, naming is confusing. So on E 5 will come, on F 6 will come, on G 7. Okay. Then after this 8, then 9. So all points are available now. So from these points I can draw the curve, but drawing the curve is also sometimes it is difficult. So you can observe here, take the curve option. See now, from this intersection point, so zoom it, zoom this thing. So from this intersection or corner I will start, to intersection I will take. See now, the curve cannot be drawn like this. So this can be done because these corners you have practiced in solids and planes while drawing the cone and circle problems. So this can be fitted, but earlier part it cannot be fitted properly. So you can press escape. See, the curve is not fitting in this problem. So what we have to do is, you take the points, the thin points you can take, 0.05, enter. So thin points you select and go on clicking on these points. So this is A first, okay, 1, this is 2 on intersection. So there are points there. Don't give the point thickness more, because in the printout it will be not required. Why? Because we are not projecting the points. These are the points which are helping to draw the curve. So go on clicking here. 7, 8, 9, 10, 12, then 1. So now I have drawn all the points. So to draw this curve, what you can do is you can use the option called Control X and Control V, okay, by keyboard, not by the software. So just what I will do is click on select option. This is very important, please concentrate here. Select complete drawing, okay, select complete drawing without points. So here if you select by box, it will select complete points as well as the lines. So don't select like this. What you can do is only select the projection lines. These are not required because we cannot fit the curve. So these lines are not required and these lines are not required. But points are required. Now what you can do is Control X you can press, that is cut option. So for some time these complete lines are hidden, and after drawing the curve you can again take out on the page. So just observe, I will press the Control X button. So this will be removed. There are points, only points are there, on that you can draw the curve. So go to curve option now. Now you observe. So 1 is here, correct? 1, 2 is here, 3 is here, 4 is here, 5, 6, 7, 8, 9, 10, 11, 12 and 1. Finished. Now you can keep the cursor properly so that curve will be smooth and press escape. Understood? Now the curve is available, which is the cut portion of the cylinder. So this curve you can make it as thick curve. So bottom projection is over now. Now what I can do? So curve I have drawn, but I need the all parallel lines. So press Control V again. So Control V you press. Now observe. Now all the lines are coming on the screen, and in that development itself you have fitted the curve. So this procedure you can follow for cone and cylinders. Now I have to draw the top curve. So again take all projection lines, again draw the points, and again draw the curve by same method. Okay, so just I will show it here, or else we can follow one more method. So you can observe here, this half of the curve is equal to this half of the curve, means A to G is equal to G to A on the top also. Always this is there in the regular figures for hexagonal prism or hexagonal pyramid, okay, or cylinder or cone, it will be regular. So only for the pentagonal pyramid or the pentagonal prism, these curves or the edges are not equal from the half. Okay, so only for the pentagonal type of or triangular type of face you can go for complete projection of lines. But here what I will do is I will take only up to G and I will mirror the remaining curve. Is that clear? So just take the projection lines now. So from these points again, so give the namings to the top plane. So take text command again. So again start naming here from here. So where we have ended up to 12 at the bottom. Now remaining points are 13 dash. So give by small font size. So that is I will take 2. So 13 dash then this will be 14 dash, which are in front. This is 15 dash, this is 16 dash, 17 dash, 18 dash, and 19 dash. Now come to behind. So 19 dash is one only corner. Here it is 20 dash in bracket. So in the bottom line also you can show in the bracket. So all the above points 8 dash, 9 dash, 10 dash, 11 dash, 12 dash are in the bracket, and in the front view from 20 to other points it is in bracket. So just I'll show here. This is 20 dash. So similar you can name in brackets. Okay, just I'll complete it. Later you can practice it. This is 21 dash. Here it is 22 dash, 23 dash, then 24 dash. So now you have seen 13, 14, 15, 16, 17, 18, 19. Then behind is 20, 21, 22, 23, 24. Okay. Now what I'll do is, these all points I'll project it on the sheet to develop it. So take the projection line again by very thin line, continuous thin line. So again from this corner, this is enough. Okay, it is cutting only 13, not 19. So this is enough. Okay, and again it is cutting at the end, so that you can place the curve exactly on that point. So up to here it will come in, so that later we will draw it from 14 and 24. So 14 and 24, where it is passing? On B and S. So that is so project it. So from 14 and 24, so 14 and 24 means it is crossing B and K. So B I have taken, then K, up to K you can take, or else I can take only B. So half of that work I will do, then I will take the mirror command. So B is done. Then one more projection you can take, 15 and 23. So 15 is cutting C and K. So only up to this I will take. 15 is over. Then 16. So 16 is on D and J. So up to D I will take. Only half I will draw. Then 17 is on E. Then 18, yes, 18 is on same line, just observe. Sorry, this 18 I have taken on E. 18 is here, so the same line again it is coming on. When it is coming, 18 is on F. After F it is 9. There are 2 points here on the same line. So just observe here 23 and 20. Yes, 23 and 20, 15 and 18 are on the same line. Okay, no problem. So just complete this curve again, same procedure. So take the points. So now observe, I will repeat the procedure what I have done earlier to draw the curve. Take points, thin points, and click here. So this is the first point, 13, first 13, then 14 here. Okay, 15 is crossing C, correct. Then 16 is crossing D, yes, done. Then 17 is crossing E line. Then 18 is crossing F line. Then last is 19, so that we have not taken. So from 19, this is the projection line which is crossing G, last line. Take it straight from 19 to G. Okay, now again give the point there. Take a point, give it here. So click it on the end. Now give the namings to reduce the confusion. So now takes font size 2. So this point is 13 dash, or leave it, no problem, it is actual. This is 14, this is 15, then 16. Okay, 15 is this bottom, then 16 is over, 17 is here, then 18 is here, then 19. Okay, so you observe here 15, where it is coming, 15 is on C, and 19 is slightly above the 15 line, so don't confuse there. So just I will move 15 below so that confusion will be less. Now again what I have to do, so select the this projection lines, all lines you select it, 1, 2, so press Ctrl and select all the lines. So only this much is enough, don't select all lines at the bottom also, so it is total waste of time. And this line, so press Ctrl X, sorry, Ctrl V you press, again return it. Okay, so properly observe here, select all the lines which are crossing the points 13 to 19, select all the lines. Done. So I have selected all the lines. Now press Ctrl X or go to select option, press Ctrl X. Now take the curve. So from 13 then 14, 15, 16, 17, where is 17? On this intersection. Okay, 17 is here. Then 18. 18 is on the same line. 18, then 19. There is 19 slightly above. So this is 19. Click there. Then come out, check for the smooth curve and press escape. So curve is fitted with the points. so there are no intersection lines, so that the curve cannot be fitted. Now select this curve, make it thick line 0.5. Now what I have to do, I have to press Ctrl V. So go to select command, select it, then press Ctrl V. Again select it, Ctrl V, or select the page and press Ctrl V. So all lines are written now. So select on the page and press Ctrl X and Ctrl V. Now you can draw from 19 to 24, from here to here. Again it will be same portion, because it is in front and behind, both the images are same. So if you cut and open the cylinder, this half from A to G is almost equal to G to A. So that what I will do is, I will go to mirror command. Now check, you know move command, rotate command, you know scale command. With that there is a mirror command, so that option you have to use here. So take the mirror command. So bottom also you can do same thing. So just I will show some sample. So select the first half curve. Okay, now with copy you have to mirror, because I want same image on the right side. So just click with the copy, then see here, if you touch this end point, okay, you touch this end point and click here, it will give the mirror command, and where you want to rotate, see how to rotate it. So what is the angle you have to give? See, at -90 it is merging with the end point, that is end point is again 13, which is on line A. So that -19, just you enter it, no problem. It is touching the end corner, enter, done. Now go to select, click it. Now this procedure is ended. Now just give the namings, over. So go to text command, 19, go on giving the points, no problem, 20, and just also observe this 20 where it is coming and properly well given or no. 21, 22, 23, 24 and 25, sorry 13, like this. So this A, 13 and 1 points are repeating here. If I join it, it will be like this cylinder which is cut by different planes. Now join the end lines. So these end lines by thick lines. So this is the remaining portion of the cylinder. Okay, this is the development of cylinder which is cut by 3 different planes. So this ends the given problem, and you can write at the developed region. So this is the required portion of the cylinder, not above and bottom portion. So there you can write the developed surface. So take some big font of, say for example 6, enter, and at the center you can write like developed portion, or else development also you can write. Okay, so this ends the development of cylinder. So similar way you can draw the prism. So in the prism, only in the place of curve there are edges. So these edges will be drawn here only. So these thick edges will be there of the given polygon, pentagon or hexagon, and like that you can join by the straight edges from 1 to 2, 2 to 3, like that in the prism. Okay, if it is hexagon, you can draw up to 3 edges. So 3 base edges you can draw half, and you can just mirror it. Or else if the pentagon solid is given, pentagonal pyramid or the pentagonal prism is given, so you have to draw completely and you have to give the namings. Okay, don't draw it half and you can mirror it in triangular solid or the pentagonal prism or pyramid. So only in cylinder, prism or any regular polygon which is having even number of sides, there you can follow this mirroring command. Okay, wherever there are odd number of edges will be there or odd number of sides will be there for the given polygon. So for that polygons you don't follow this mirror command options. So do it completely. So I hope this problem is understood to all. Okay, thank you.